All right, so welcome to New Building Blocks for Deploying on Kubernetes. My name is Enrique Encalada, and today, together with Manno from SUSE,
Hi.
We're going to give you the latest updates on the Quarks CF operator. So just as a reference, we already did a talk about the CF operator this year in the summit in Philadelphia. And just go online and take a look. It's a very high-level approach on what we're doing. And you see the red arrow, that is me, and that's how much you will see about me during the whole presentation. So hopefully that will not happen today. But anyway, the point I would like to stress here is that during the summit in Philadelphia, the theme was called containerization. And after the summit, we realized that there was a lot of confusion about who was containerization team. A lot of people thought that Irene was containerization. And we came up with the idea that maybe we should be more visible in the community. And that's why we came up with the name Quarks, which is a little bit more fancy. So this picture just wants to illustrate like one of the main goals of Quarks, which is basically we want to put Cloud Foundry in the same boat as Kubernetes. The thing is like we want to allow users to deploy Cloud Foundry, but actually we want them to be able to do this in a very Kube native way. And I think this is one of the main things that that the Quarks team is doing at the moment. We're using the state of the art when it comes to Kubernetes, usage of packages and best practices in order to build the Quarks CF operator. So let's take a look a little bit for who is this talk intended. So I guess here there are three main things. This talk is intended for those people that are interested in running Cloud Foundry natively in Kubernetes. Also, this talk is for those people that wants to know more about the Quarks CF operator and its main functionalities. And last but not least, is also for those people that are thinking on how to automate operations in Kubernetes. And I think this is a very important selling point. At the end of the day, we will speak about a deep dive on how the CF operator works and which are the main components. But there is a lot of learning in this presentation that, of course, you could take with you and maybe implement that later in your projects. So while we're speaking about Quarks, it's important to know who is the Quarks team and where they are located. So we are spread around the world. We have the team lead in Romania. We have interns in UK, one IBM developer in China. Most of the developers are in Germany, 3 of them from SUSE in Nuremberg, and I am in Stuttgart. We have also developers in Canada, the PM in the host country. Yeah, so next slide is really important, and it's just a way that I would like to stress what is Quarks and what is not Quarks. So Quarks is not the scheduler, and I will go into that in a minute. But let's see what is Quarks, or what is the Quarks team. So we are the entity that deploys Cloud Foundry in Kube. If you take a look at the moment on the public offerings like CAP and SIFI, they do that through SCF and the help of Helm. If you will take a look on how you will do it in the future with the CF operator, you will no longer use Helm to do that, but well, you still need Helm to deploy the CF operator, but the way you describe the Cloud Foundry instance is through a YOML that is basically the BOSH manifest. The second thing is that we are the config management, the way you would like that Cloud Foundry instance to look on your Kube, where we have those YOML files and everything is under SUSE SCF. We are also the containerization. That means that we have the binary that allows you to convert a set of BOSH releases into Helm charts and Docker images. So you will have a suitable set of things that you can deploy in a Kube cluster. And at the very end, we are the CF operator. The CF operator is basically this Kubernetes operator concept that we implement, and basically we allow you to take a BOSH manifest and convert that into Kube resources, so that at the end of the day, you will have a Cloud Foundry running in the cluster. So what we are not is the scheduler. The scheduler is Kube, and that's what the Irene team does. They take advantage of that scheduler to schedule the applications in your cluster.
Okay, so the CF operator, sorry? Oh, that's an operator in the sense of the Kubernetes operator, not in like an operator in front of a machine. And Kubernetes operators are called like that because they are kind of automation device. You use them to replace operators, like they automate stuff. And this is a nice concept because it's then repeatable and reusable. But it's also a nice concept because it works natively on Kubernetes. There are facilities in the software to extend the existing APIs with your own APIs and your own objects. But what we are doing here is like, we are not doing the scheduler, we are basically deploying BOSH releases on Kubernetes, and Cloud Foundry is a BOSH release. And the big improvement here is with regards to SCF version 2 is that the operator gives us the ability to do this much better than we did this before. So one of the big advantages, and you already might have seen this in the keynote, is that we are now split in build time and runtime. And before, everything was happening at build time, and a lot of the logic was happening there. But now we just have this fissile part at the top, which builds the images. And this has to be done before. We have like a pipeline that builds all the images for all the BOSH releases we need. And then the part below that, like, the bottom half of the picture, this is like a black box view on the operator. And you take the normal CF deployment, like the normal BOSH deployment manifests, you put them into the operator, and it starts to create resources, watch for resources in a reconciled state. And in the end, you end up with the runtime workloads, like with the Cloud Foundry on Kubernetes. So a little bit of why are we doing this? Like, why was SCF? Why does it have pain points? And what were these pain points? For once, we wanted to be more BOSH native, like support the original BOSH manifest, just with a few additions, but not change them too much, so we can consume the upstream resources much faster than before and with less work. It also makes our images much smaller than in version 2, because now there's a separate image for each release. And like I said, the Helm chart has less logic. Since so much is happening at runtime, this allows us to do much more granular updates. Like when you change a part of the manifest, not everything is deployed again, but only the parts that changed. Why wasn't Kube enough? Why not throw it all to Kube and be done with it, right? We wanted to use the original BOSH manifest, right? We wanted to apply the operations files, which are a great concept, I think, to modify CF deployments. We wanted to apply them and not have the user apply those before. And we had a need to version Kubernetes resources so we can keep them around until the new one is ready. And a lot of the installation of Cloud Foundry is about generating resources and having the right certificates in there. We can, this will be shown later in the deep dive, we can do this like on Kubernetes and generate these directly into Kubernetes secrets. All the template rendering will be a huge part of the presentation. Template rendering at the moment is hard, like taking the BOSH manifests and turning them into something Kubernetes understands. And I think one opportunity we have here, and they're not completely feature complete yet, but is the lifecycle management of instances, like canary deployments, blue-green deployments, all the things you have to add on to Kubernetes in some fashion. So the building blocks, the operators, how does an operator work in a technical fashion, right? Like we are following this pattern here, which is we watch resources. When they change, we analyze the cluster. We analyze the current state. We don't look at historical events, take what's there, and then we act to produce the desired state. This is how Kubernetes operators mostly work. And a lot of the resources we watch are custom resources, these API extensions. We have a bunch of them. And this is all happening at the same time, asynchronously. So that's really like things in Kubernetes happen. This is a really big chart. I tried to split it into 3 separate layers. Oh yeah, I can see it now. We start here with the deployment component. We have several of those components and the gray boxes. There's also the extended secret component and the extended stateful set and the extended job component. The blue boxes here, they are native Kubernetes resources. The yellow ones, they are like custom resources we created. And the green ones, they are just intermediate resources we create, but they are not required for the end product. And if we follow the flow here from the top, the user is going to create a BOSH deployment custom resource, and it has a reference to an ops file, to a list of ops files, has a reference to the BOSH manifest, which could be stored in a Kubernetes config map or secret. And all the implicit variables from the BOSH manifest, they have to be in Kubernetes secrets too. So once you created that, you create the BOSH deployment resource, it will trigger the deployment component. And this will create an extended secret. Extended secret will take care of all the explicit variables like certificates and passwords, but you will go into more detail later, I guess. And this will end up like here in these instance group manifests, BPM configs, and finally in the desired manifest, which is like the completely rendered manifest with all the variables. This is fed back into the deployment component and then converted into Kubernetes objects, which correspond to BOSH objects, namely to instance groups and errands, here in the lower right. And once we have those extended stateful sets and extended jobs, there's a one-to-one mapping. The extended stateful set and the extended job component can take care of those and finally transform them in what I call here the deploy phase, transform them into stateful sets on Kubernetes and jobs on Kubernetes, which then start up the pods and the containers inside the pods. I just put 4 red dots here to show which resources a user will normally interact with. These are safe to override. So you can create those, you can change those, and the deployment should adapt. So each component is made up of several parts, and Enrique is going into details.
Hello, can you hear me? Hello? Okay, that's fine, sorry. Yeah, so this is a high-level diagram of the CF operator and its interactions with the 9 controllers we have. So we came up with a concept of components. So we want each component to host a set of controllers. So this will help us to simplify the explanation. But in general, we have 4 components. We have the BOSH deployment component, we have the extended job component, the extended secret component, and the extended stateful set component. So now I will try to do a deep dive into each of the components, trying to explain all the controllers and the flow between each of them. And this is basically the way the engine of the CF operator works. So once the end user provides a BOSH deployment, the engine will run, all of these interactions will take place, and eventually you will end up with a Cloud Foundry instance running so that at the end of the day you can do a CF push. So before we go to the components, I guess the first step is to understand how can you deploy the CF operator. And basically this is a GIF file. If you pay attention to the top command line, I basically run helm to install the charts of the CF operator. If you would like to try it yourself, just go to the GitHub of the CF operator and you will find the charts there. And on the bottom, the command line on the bottom is basically watching for pods in the SCF namespace. And eventually you will see that a CF operator comes up. And this operator is basically a binary that will be a long-running application. And he will be basically sitting there waiting for the end user input to provide a BOSH manifest. So let's take a look on each of the components. As I say, the first one is the BOSH deployment component. It has 3 controllers: the BOSH deployment, the generate variables, and the BPM controllers. While I'm moving to the next slides, I will explain it in a way that you will see relationships between these 3 controllers with the next components. So this is the most important component because it basically hosts the BOSH deployment controller, and this guy is the one that will read your BOSH manifest and trigger the conversion of BOSH into Kubernetes resources. So if you pay attention to the picture we have here, that's how you will define the BOSH deployment instance. There are two main keys. On the spec, you will see manifest and ops. Manifest is basically the key that will host a reference to an ops files, and in that ops file is where you will define the BOSH manifest as you know in the traditional BOSH way. The second key is ops, which is a list of reference to config maps, where you will define per config map BOSH ops files, basically because you usually want to override things on top of the base YAML. So on the following slide, what I will show is I will cut a YAML file where I have the definition of that BOSH deployment, but also I define the config maps I reference in that BOSH deployment instance. So you will see it now. I cut that file, and the first thing I show is the BOSH deployment instance definition, and I reference to config maps. The first config map is an ops file where I want to replace NATS instance groups with a value of 2. And the second one is basically the BOSH manifest as you know it. Releases, instance groups, variables, and I also make a reference to a custom password, which is a BOSH variable. In this case, you could define explicit secrets. That basically means like, by default, it generates the secrets, but if you would like to define a custom value, you can do it by defining that secret in the same namespace. So this is basically what the end user needs to do at the beginning. And then let's see what happens when you apply or create that file into the same SCF namespace. So if you pay attention on the top, we basically apply that file, we generate config maps and a BOSH deployment instance. And on the bottom, what happens is you have the CF operator running. The yellow things you saw, they were cube jobs at the start. They perform an interesting task, then they finish. And eventually what we want to see is 2 pods running each of them NATs because we wanted 2 instance groups of NATs. So now let's try to do a more, let's go into details with actually what happens under the hood with this flow. Also, important thing to notice, this is a very small scale. What we have achieved till today is like you can define a more complex BOSH manifest. You of course need to define a longer list of ops files. And eventually what you will see here is not just 1 or 2 pods of NATs, you will see all the Cloud Foundry components running in pods. And at the end of the day, as I say, you will be able to CF push an application. All right, so let's speak about the extended job component. The extended job component hosts 2 controllers, the job and the errand controllers. And this is, I guess, one of the favorite set of controllers that we have in the team because of the features. The first thing is that this is a very generic set of controllers. And we actually are thinking on isolating them from the upstream code, make them like a single controller that we eventually could contribute to the community of Kubernetes. The second thing is the features it has. It basically allows you to run interesting tasks, basically means whatever you want to run, and it could grab the standard output that task is going to generate, and that standard output could be stored in a secret, and you could version the secrets. So this is really powerful if you want to run something in the middle that you know that someone needs to consume at a later point. You can also trigger these controllers in different modes. It could be automatic or manual, and so on. So now, as this is a deep dive, and I know it's a little bit late, just stay with me. We need to see how is the flow between the BOSH deployment controller and these extended job components. So basically, the picture to the left is like the BOSH deployment controller. So if you recall, when I apply that YAML file, what is going to happen is like this controller is waiting for someone to create this type of resources. As soon as this happens, controllers by nature will try to reconcile. Basically, they would like to put what you're telling him to put in the cluster if that resource is resource is not there in the cluster. So when the BOSH deployment controller reconciles, he will perform 4 tasks. The first one is he will generate a secret with apply ops files. Basically, we'll take the base BOSH manifest, apply the ops files on top, and store that output in the secret. And the next 3 tasks is he will generate extended jobs. Basically, here we're just like dealing with, as you know, CF operator runs all the jobs with BPM. So for BPM, in order to run, we need to have specific data. So we will render the BPM, we will generate the right values for the BPM config, we will generate BOSH links and so on that we need to have there. And eventually, when we generate extended jobs, we will see the 2 extended job controllers in action. So the first thing is like the errand controller. He's waiting or watching for extended job instances creation. And once that happens, he will reconcile. The reconcile will generate Kubernetes jobs. And this will eventually generate a standard output. At the same time, you have a second controller, which is the job controller. He will read that standard output and persist that valuable data into a secret in the same namespace. Again, this is just an example. In the left command line, we basically applied the YAML file we saw. And on the top right, you see that we generate 3 instances of extended jobs. And on the bottom, we will see eventually 3 secrets that are owned by that extended job. And these secrets data will be used later. All right, so let's move to the next component. This is the extended secret component. And this is a very simple controller because it basically just generates secrets for us. But the nice thing about it is that he will actually get all the variables that you define in your BOSH manifest and convert them to extended secrets. So this set of controllers, they can generate for you passwords, SSH keys, SSL certificates, clusters certificates, and self-signed certificates. If we go to the flow again about one of the controllers from the BOSH deployment component, which is the generate variables controller, we could see that once the user applied that YAML file, he will reconcile and he will just basically list all the variables and generate extended secrets. Once extended secrets are generated, there is the extended secret controller, which is the yellow in the left. And he will basically be watching for generation of extended secrets. So once that happens, he will, again, as the nature of controllers, reconcile, generate secrets. And in the case that you want to generate a certificate signing request, that will be processed by a second controller, which is a certificate signing request controller. So this is just an example in the command line after we apply the BOSH manifest YAML. You will see that there is a new instance of extended secrets in the same SCF namespace. As I say, just continue with me. It's a little bit too much, I know, but this is the last component. So this is the extended stateful set component, and it has 2 controllers. The nice, or the way you could see extended stateful sets components or controllers, is like you could understand them as the ones that will translate your BOSH instance groups into Kubernetes stateful sets. All right. Also, these controllers are really powerful because the stateful sets that they generate, they could version the stateful sets. So if you could version a stateful sets, you can achieve things like blue-green deployments. And again, this picture is just an example of how you will define the extended stateful set instance. And if you take a look, it's basically like a wrapper around the same definition of a stateful set in Kubernetes. Well, sorry. So again, this is the flow between one of the controllers from the BOSH deployment and the extended stateful set components. What happens is, like, if you recall when I spoke about extended jobs, they generate secrets with valuable data. So what is going to happen here, we have the BPM controller. He realized when those secrets are generated, and he eventually will trigger the creation of extended stateful sets. When that happens, we have, of course, the extended stateful set controller. He will realize that there is a new extended stateful set instance, and eventually he will end up creating Kubernetes stateful sets that are versioned. We also have a controller. Whenever you update that extended stateful set and you have an old version, we use this controller to do a proper cleanup. Also in this flow, you will generate services if you need to access the pods at a specific port, and volumes is the same. We will generate also volumes. Again, here is just, I'm watching a lot of things in the SCF namespace. I watch for extended stateful sets resources. You could see that there is one generated. And here I just show the contents of the extended stateful set, which I guess is too much for now, so I will just skip that. So I guess that was most of the deep dive we wanted to do with controllers and their interactions. I know this is a little bit too heavy, but this is something we need to share with the community because it's really important for everyone to be aware of the insights of the CF operator.
Thanks. Yeah, one thing I liked about the resource earlier is that we reuse Kubernetes structs in there. So even our custom resources borrow from what you already know about Kubernetes. Well, okay. So what is up next for us? And I think we want to be a feature. Want to have feature parity with BOSH director, because we don't have a BOSH director here anymore, right? Because it's VM based, and we really want to extract some of the components to make them reusable for other projects. I think extended job could go first, then extended secret, and extended stateful set. I think has the biggest potential once it supports all the features we want in there. When you come to the hands-on lab session tomorrow, if you want to and try it out on your laptop, you will see that if you run into problems, you will see that webhooks are a huge configuration problem for us at the moment. Kubernetes webhooks are really difficult because they are cluster-wide and so on, and we hope this can improve when we can require Kubernetes 1.15. Yeah, we hope to be part of SCF version 3 soon, which will make lives a whole lot easier with the smaller images and the updates and all of that. And like probably every dev team out here, we want to improve our CI. Running tests on Kubernetes, like running tests on every infrastructure is tiresome. And there's something like Kubernetes and Docker, and that's what we are going to try next. We are really looking forward to that. Yeah, so if you want to know more about us or want to look in, we do have a Slack channel. You can take a look at our repository or come by the hands-on lab session tomorrow, and we also have like office hours tomorrow here. So yeah, I think that's it. If you have any questions, please go ahead.